8.4 expected counts and two-way tables, and this is going to be the fastest video ever. So this is just a skills video. There's not a lot of explanation here. So just how do you calculate expected counts for a two-way table of categorical categorical data, okay? And it's super duper simple. So the essential knowledge here is just the formula. Expected counts in a two-way table are row total times column total divided by the total number in the sample or in the study or in the table or however you want to think about that. Okay, so just a quick review on using two-way tables because it's been a hot minute. I'm going to move myself so that I can read it. It says a large national bank determines if each of its branches is profitable or not profitable. Additionally, the location of each branch is classified as urban, suburban, or rural. A summary of the profitability and location type of of a random sample of 175 of the bank's branches is shown in the table, okay? So you can see here's the table of the banks, profitable, not profitable, urban, suburban, rural, okay? And remember when we did this, I always find it easier to just go ahead before you answer any questions on it and get your totals if they're not given to you, okay? So how many profitable? 121, add. How many not profitable? 54, add. Double check your 175 sample here by adding profitable plus not profitable. There's only two things the bank could be. I guess they could be a break even, but they didn't give us that. And then your urban, 81 urban banks, 61 rural banks, and 81 urban, 61 suburban, and 33 rural. And then again, you should be able to add and get 175 again. Okay. So now that we have our totals, we'll probably answer some questions based on this. From the sample of 175 branches summarized above, what's the proportion of branches that are profitable? What proportion of branches, so this would be all the branches, are profitable, right? So now we've already added up our profitable, that's 121, out of 175 banks, and we get 69% of our banks are profitable. Yay. We just hope they're more profitable than the not profitable. If that makes, obviously they are, but you know what I mean. What proportion of branches from an urban location are profitable? From an urban location tells you that's the denominator, okay? From an urban location. There are 81 banks that are an urban location. What proportion of these 81 banks are profitable? 64. So 79% of urban banks are profitable. What proportion of banks from a rural location are profitable? From a rural location tells you that's the denominator. There are 33 banks that are rural. I hate that word, by the way. How many are profitable? 18 of them. So 18 of the 33 rural banks are profitable, or 55%. Okay, remember. Okay, so now the quick lesson for today. If I wanted to know the expected counts for this table, okay? If I wanted to know what I should expect to see, not what I did see, not what I observed, but what I should expect to observe for example, for a profitable for a profitable urban bank based off of all the other information, okay? Then I do row times column divided by total. So there are, I just pointed at the screen like you could see that. There are 81 urban banks. There are 121 profitable banks. So I'm going to do, wow, I forgot to put the formula up there. Smart, I'm a smart cookie. We're going to do, I just lost it. 81 times 121 divided by the 175 banks, okay? Profitable times urban divided by total. So we should expect 56 of those banks to be profitable. Turns out there's 64. What about not profitable? There's 17. What would we expect? Well, we're going to do urban times not profitable divided by the total. We would expect to see about 25 banks. We only saw 17. And we keep going with this, suburban and profitable. So profitable total times suburban total. I'm really in the way for you to be able to see this. There we go. Profitable total times suburban total would be 121 times 61 over 175. Remember, multiplication is commutative. Doesn't matter which one you put first. Expected values, 42.18. And keep going. Not profitable, 54, times suburban, 61, divided by 175. Rural, 33, times profitable, 121, divided by total, 175. 22.82 expected, 18 observed. One more time, profitable, not profitable, and rural. Not profitable and rural. These are hard words today. 54, not profitable. 33 rural, divided by the 175 total. I would expect to only see 10. Instead, I saw 15. Okay, that's how you find the expected count of a two-way table. So real quick, just to make sure you got it. The National Park Service writes materials for students to use while in the parks. In a study of the effectiveness of some of these materials, a random sample of students was selected to take a short quiz about oak trees after using these materials. A random sample of park professionals also took the quiz. Investigators compared the classifications low, medium, and high of the crown shapes, the general shapes of the leafy parts of the trees made by students in grades 6 through 12 with classifications made by professionals. Data from the study are shown. If the professionals and the students do not differ in the distributions of their responses, which of the following is equal to, which of the following? Obviously, I pulled this off a multiple choice question. What would be, basically, what would be the expected number of students who classify the crown shapes as medium? So we see that, what's the expected number? We see a two-way table, and we go to the formula row times column divided by total. Okay, so what rows and what columns am I multiplying? Well, number of students classified as medium. So I've got medium, which is 87 in the study, and students who are 91 in the study, and a total of 200 in the study. So I would take 91 times 87 divided by 200, and that means I would expect to see 39.6 students who prefer medium. And actually the expected and the observed are quite similar in this case. Okay, guys, that's it. That's all you need to learn today is how do you find expected value in a two-way table, row times column, divided by total, every time. Good luck. Bye.